Hi friends, welcome to my channel. Before going to the video, those who are not subscribed our channel, subscribe it and also click the bell button. In this video, we are going to see about nodal and mesh analysis. Nodal analysis and mesh analysis are the two basic circuit analysis techniques which allow us to investigate many different circuits with a consistent methodological approach. First, we will see about nodal analysis. Nodal analysis is one of the circuit analysis method which is based on KCL and Ohm's law, that is Kirchhoff's current law. Kirchhoff's current law states that the algebraic sum of currents meeting at any junction or node is equal to 0. That is, the algebraic sum of currents entering the junction or node is equal to the algebraic sum of currents leaving the junction or node. As we all know, the Ohm's law states that the potential difference between two ends of the conductor is directly proportional to the current flowing through the conductor. For a circuit with of nodes, the number of independent nodal equations or KCL equations is given by n minus 1. In nodal analysis, we will determine the voltage between nodes. That nodes are nothing but the points where elements or branches meet in the electric circuit in terms of branch currents. Nodal analysis is applicable to both planar and non-planar circuits. Planar circuits are the circuits that can be drawn on a plane surface with no wires crossing each other. Non-planar circuits are the circuits that cannot be drawn on a plane surface without wires crossing each other. Now let us see the steps to solve problem using nodal analysis method. The first step is we have to identify the number of principal nodes present in the electrical circuit or network. Principal nodes are the nodes in which current division occurs. Next, we have to ground one of the principal nodes. This is the reference node. The next step is for all other principal nodes, we have to form the nodal equations by applying Kirchhoff's current law and Ohm's law. Then we have to solve the nodal equations to get the node voltages. Important note we have to remember is while considering one node, we have to assume that node voltage is higher than all other nodal voltages. Hence, entering current to a node is given negative value and leaving current to the node is given positive value. Now let us solve a problem. Find the current through the 2 ohm resistor using nodal analysis. The circuit is given here. For this circuit, we have given independent voltage source 10 volt, independent current source 2 amps and resistor values 1 ohm, 5 ohm, 2 ohm and 10 ohm. In this circuit, the number of principal nodes are 3, that is A, B and C. Let us consider the C node as the reference node. Let the voltage at node A is VA and the voltage at node B is VB. At node A, since we are assuming the voltage VA is superior to all other voltages, all the currents here are leaving currents. The current through 1 amp is VA minus 10 divided by 1 ohm. The current through 5 ohms is VA by 5. Similarly, the current through 2 ohm is VA minus VB divided by 2. According to KCL, the algebraic sum of all this current is equal to 0. Now, taking 10 as the LCM, we have 10 VA minus 100 plus 2 VA plus 5 VA minus 5 VB divided by 10 is equal to 0. Simplifying, we have 17 VA minus 5 VB is equal to 100. Let us take this as the first equation. Now, consider node B. Let this voltage is superior to all other voltages. Here the entering current is 2 amps and the leaving currents are current through 2 ohm and 10 ohm. The current through 2 ohm is nothing but VB minus VA divided by 2. Similarly, the current through 10 ohm is VB by 10. So applying KCL, we have VB minus VA by 2 plus VB by 10 is equal to the entering current 2 amps. Now taking 10 as the LCM, 5 VB minus 5 VA plus VB divided by 10 is equal to 2. Simplifying, we have minus 5 VA plus 6 VB is equal to 20. Let us consider this as the second equation. Solving equations 1 and 2, we get the nodal voltages, that is the voltage at node A, VA is equal to 9.09 volt. Similarly, the voltage at node B, VB is equal to 10.9 volt. They were asked to find the current through resistor 2 ohm. So, the current through resistor 2 ohm can be calculated by using the formula I2 is equal to VA minus VB divided by 2. Here we are assuming that the current flows from A to B. Now substituting for VA and VB, we have 9.09 minus 10.9 divided by 2. So I2 is equal to minus 0.905 amps. This gives the value of current through resistor 2 ohms. Here the negative sign indicates that the current I2 flows from node B to A. Remember that if we get negative sign, the actual current flows from direction opposite to that of assumed direction. Now let us see mesh or loop analysis. A loop is any closed path in an electrical circuit in which no node is encountered more than once. A loop can have many other loops inside it. A mesh is nothing but it is also a loop that has no other loops inside it. From this we can conclude that all meshes are loops, but all loops may not be mesh. Mesh or loop analysis is based on KVL and Ohm's law. KVL is nothing but Kirchhoff's voltage law. Kirchhoff's voltage law states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the loop. And this sum is also equal to 0. In mesh analysis method, we will determine the current circulating around a loop or mesh within any closed path of the circuit. Here, if the circuit has n number of nodes and b number of branches, then the number of independent mesh equations or KVL equations is given by b minus n plus 1. This mesh analysis is applicable only to planar circuits. Planar circuits are the circuits that can be drawn on a plane surface with no wires crossing each other. Next, let us see how to solve problem using mesh analysis. First, we have to identify the number of meshes present in an electrical circuit or network. Next, we have to name the mesh currents as I1, I2, I3, etc. Next, we have to form the mesh equations by applying Kirchhoff's voltage law and Ohm's law to all the meshes. By solving these mesh equations, we will get the mesh currents. Important note to remember is, while considering one mesh, assume that particular mesh current is superior to all other mesh currents. Next, assign clockwise direction to all the mesh currents in the electrical circuit or network. Actually, we can assign either clockwise or anti-clockwise direction, but same direction have to follow for all the currents. But it will be convenient if you choose clockwise direction. Next, let us solve a problem on mesh analysis. For the circuit shown in figure, find the mesh currents, current through 40 ohm resistor, and also the power dissipated in it. The given circuit, there are two independent voltage sources. One is 10 volt and other is 20 volt. And three resistors. R1 is equal to 10 ohm, R2 is equal to 20 ohm and R3 is equal to 40 ohm. And the mesh currents are I1 and I2. First, let us consider the mesh 1 or loop 1. Now, applying Kirchhoff's voltage law to loop 1 or mesh 1, we have 10 volt minus 10 into I1, which is nothing but drop across the resistor R1 minus 40 into I1 minus I2. This is the drop across the resistor 40 ohm is equal to 0. Simplifying, we have 50 into I1 minus 40 into I2 is equal to 10. Let us consider this as equation 1. Now let us consider mesh 2 or loop 2. Applying KVL to loop 2, we have minus 40 into I2 minus I1. Here we are considering I2 is superior than I1. Minus 20 into I2 minus 20 is equal to 0. Since here the current direction is from plus to minus, we have 20 volt as drop. Hence it is indicated by minus sign. But if you see 10 volt, as we move on the direction of current, we move from minus to plus. Hence it is given positive value. The drops across the resistor are given negative value. Now simplifying, we have 40 into I1 minus 60 into I2 is equal to 20. Let us assume this as equation 2. Solving equations 1 and 2, we have I1 is equal to minus 0.143 amps and I2 is equal to minus 0.429 amps. These are the mesh currents or loop currents. Now, the current through resistor for 40 ohm can be calculated as I 40 ohm is equal to I1 minus I2. Here we are considering I1 is superior to I2. Substituting for I1 and I2, minus 0.143 minus of 0.429, we have current through 40 ohm resistor as 0.286 amps. Now, the power dissipated in the 40 ohm resistor can be calculated by using the formula power is nothing but I square into R. Here R is equal to 40 ohm. The current through the resistor 40 ohm is 0.286. Substituting that, we have P 40 ohm is equal to 0.286 square into 40, which is equal to 3.272 watt. Hence, the power dissipated in the 40 ohm resistor is 3.272 watts. Now, let us see the previous year questions. First question, for the circuit shown in figure, the terminal voltage is given by. This question was asked in June 2014 and they have given the circuit which has dependent voltage source 3 VAB and independent voltage source 4 volt and independent current source 2 amps and a resistor 10 kilo ohm. Options are A 5 volt, B 6 volt, C 2.5 volt, D 3 volt. Here the answer is B 6 volt. Let us see how we got this. Let us solve this problem using mesh analysis. Assume a mesh current I. Now applying Kirchhoff's voltage law, we have 4 minus 10 into I minus 3 VAB minus VAB is equal to 0. Here the voltage across 2 amps is VAB. Since it is a drop, we are taking it as minus. That is, as we move from the direction of current, we go from plus to minus. Hence it is considered as drop. From the circuit, we can understand that this mesh current I is nothing but minus 2 amps, since it is opposite to the direction of current source. So substituting for that, 4 minus 10 into minus 2 minus 4 VAB is equal to 0. So 24 minus 4 VAB is equal to 0. 4 VAB is equal to 24. So VAB is equal to 6 volt. Hence the terminal voltage of the given circuit is 6 volt. Second question. In the figure, how much is the voltage around partial loop CEFD and how much is the voltage around loop CEFDC? This question was asked in June 2015. In the circuit given, there are two voltage sources. V1 is equal to 84 volt and V2 is equal to 21 volt. And resistors, three resistors are given. R1 is equal to 12 ohm, R2 is equal to 3 ohm and R3 is not given, and the voltage drop across R3 is given as 24 volt. Similarly, voltage drop across R1 is 60 volt, R2 is 3 volt. If you consider the partial loop CEFD, the current direction must be in clockwise direction. For resistor, the terminal at which current enters is given as positive and the terminal through which current leaves is given as negative value. But here it is given minus plus. So the voltage across resistor R2 is minus 3 volt. Similarly, if you take the voltage source 21 volt, as we move on from the direction of current, it goes from minus to plus. Hence it is also minus 21 volt. So the total voltage across the partial loop CEFD is minus 3 plus minus 21, which is nothing but minus 24 volt. If you consider the loop CEFDC, as we move on in the direction of current, the voltage across R3 is, we go from plus to minus. So it is a drop. Hence it is given positive value. That is, the terminal at which current enters is given positive and the terminal through which current leaves is given negative. So the drop across VR3 is considered as positive, 24 volt. So the total voltage is minus 24 plus 24, which is equal to 0 volt. Hence answer D is correct. Next question. The power dissipation in the resistor R4 of the following circuit is. This question was asked in July 2016 and they have given the circuit diagram. The circuit has one independent source 100 volt and one series resistor 40 ohm and all the other resistors are parallel. R2 is equal to 33.3 ohm, R3 is equal to 50 ohm, R4 is equal to 20 ohm. The options are A 10 watt, B 15 watt, C 20 watt, D 100 watt. So here the answer is C. Let us see how we got this. We shall solve this problem using nodal analysis method. In this circuit there are only two principal nodes and let us consider the bottom node is grounded, that is the reference node, and the top node is A. The voltage at this terminal is VA. We have to assume that this voltage is superior to all other voltages. Hence, by applying KCL, we have VA minus 100 divided by 40. This is the current through resistor 40 ohm plus VA by 33.3. This is the current through resistor R2 plus VA by 50. This is the current through 50 ohm plus VA by 20. This is the current through resistor R4 is equal to 0, since here all the currents are living. Now for simplification, I am replacing this 33.3 as 3 by 100. So taking 200 as LCM, we have 5 VA minus 500 plus 6 VA plus 4 VA plus 10 VA is equal to 0. Simplifying, we have 25 VA is equal to 500. So VA is equal to 500 by 25, which is equal to 20 volt. That is, the nodal voltage is 20 volt. Now the power dissipation in the resistor R4 can be calculated by using the formula power is nothing but voltage square by resistance value. So PR4 is equal to BA square divided by R4, which is equal to 20 square divided by 20. So PR4 is equal to 20 watts. That is, the power dissipated in resistor 20 ohm is 20 watt. Hence option C is correct. Next, fourth question. Consider a two-mesh network as shown in the figure. This question was also asked in July 2016. They have given two independent sources, voltage sources. E1 is equal to 120 volt, E2 is equal to 65 volt, and three resistors. R1 is equal to 40 ohm, R2 is equal to 60 ohm, and R3 is equal to 20 ohm. The mesh currents are I1 and I2. The values of I1, I2 and IBD are computed as: first one, I1 is equal to 1.885 amps, I2 is equal to 0.341 amps. Second one, I1 is equal to 1.885 amps, IBD is equal to 2.23 amps. Third one, I2 is equal to minus 0.341 amps, IBD is equal to 1.885 amps. Fourth one, I2 is equal to minus 0.341 amps, IBD is equal to 2.23 amps. The question is, which of these computations are correct? Option A 1 and 2, option B 2 and 3, option C 3 and 4, option D 2 and 4. Consider loop 1 or mesh 1. Applying Kirchhoff's voltage law, we have 120 minus 40 into I1 minus 20 into I1 minus I2 is equal to 0. Simplifying, we have 60 into I1 minus 20 into I2 is equal to 120. Let us consider this as equation 1. Next, consider mesh 2 or loop 2. Applying KVL, we have minus 20 into I2 minus I1 minus 60 into I2 minus 65 is equal to 0. Simplifying this, we have 20 into I1 minus 80 into I2 is equal to 65. Let us consider this as equation 2. Now, solving these two equations, we have I1 is equal to 1.885 amps and I2 is equal to minus 0.341 amps. From the figure, we can see that IBD is nothing but current through resistor 20 ohm, which is equal to I1 minus I2. So IBD is equal to 1.885 minus 0.341, which is equal to 2.226 amps. So here option D is correct. Next question. This is assertion and reason type. This question was asked in Jan 2017. First assertion. It is convenient to write loop equations for a network containing voltage source but no current source. Reason. If the current sources are present, then these must first be converted into their equivalent voltage sources. Here both the assertion and reason are correct, but reason is not the correct explanation of assertion. Next question. This question was asked in July 2018. Consider the following network. They are given the circuit. It has two voltage sources, independent voltage source. E1 is equal to 5 volt, E2 is equal to 10 volt, and resistor R1 is equal to 4 ohm, R2 is equal to 2 ohm, R3 is equal to 2 ohm. First, the power dissipated in resistor R1 is P1. The power dissipated in resistor R2 is P2. The power dissipated in resistor R3 is P3. Arrange the above in increasing order of the dissipated power. Which of the following options are correct? Option A 1, 3, 2, option B 1, 2, 3, option C 2, 3, 1, option D 3, 1, 2. Here there are only two principal nodes, top node and bottom node. Let us assume that the bottom node as reference node. So top node as A. So voltage at its VA. Using nodal analysis, and applying Kirchhoff's current law, we have VA minus 5 by 4, that is the current through resistor R1, plus VA by 2, that is the current through resistor R3, plus VA minus 10 divided by 2, that is the current through resistor R2, is equal to 0. Since here all the currents are leaving the node A. Taking 4 as the LCM, we have VA minus 5 plus 2 into VA plus 2 into VA minus 20 is equal to 0. So simplifying, we have VA is equal to 5 volt. The power dissipated in resistor R1, which is P1, is equal to 5 minus VA by whole square by 4. Since power is nothing but voltage square by resistance value. Here the voltage is 5 minus VA is the voltage drop across resistor R1 and the R1 value is 4. So we have P1 is equal to 0. Similarly, the power dissipated in resistor R2 is P2 is equal to VA minus 10 the whole square by 2, which is equal to 25 by 2, which is equal to 12.5 watt. Similarly, the power dissipated in resistor R3 is P3, which is equal to VA square by 2. VA is equal to 5 volts. Substituting for that, we have P3 is equal to 25 by 2 is equal to 12.5 watt. Here, since none of the above options are correct, they have given marks for all the candidates. Next question, assertion and reason type. This question was asked in July 2018. First assertion, all the mesh currents are necessarily the loop currents, but all the loop currents may not be the mesh current. Reason, the mesh current is the current which flows only around the perimeter of a mesh. We know that mesh is a loop which has no inner loops. So all the mesh currents are loop currents, but all the loop currents may not be the mesh current is correct. And also mesh current is the current that flows around the perimeter of a mesh. This is also correct. So both assertion and reason are correct, and reason is the correct explanation of assertion. Last question. This question was asked in June 2019. The nodal method of circuit analysis is based on, first one, KVL on Ohm's law. Second one, KVL, KCL and Ohm's law. Third one, KCL and KVL. Fourth one, KCL and Ohm's law. Which of the following options are correct? Option A, 1 and 2 are correct. Option B, 3 and 4 are only. Option C, 4 is wrong but 1 is correct. Option D, 4 is correct but 2 is wrong. We know that the nodal analysis is based on KCL, that is Kirchhoff's current law, and Ohm's law. So fourth one is correct but second one is wrong. So option D is correct. Thanks for watching the video. For more videos, don't forget to subscribe our channel.